Okay, this is the second example here again, looking at two sample t-tests for means, two sample t-intervals for means. Why don't you pause me and give this a read? Okay, so we're testing here to see if calcium can reduce blood pressure. We happen to be focusing on black men, so we've got 21 healthy black men randomly assigned, 10 to receive calcium, the other 11 to receive a placebo. We're measuring the decrease in blood pressure here, so it's a little funky in the wording, but it says an increase in blood pressure appears as negative, which would tell us that a decrease in blood pressure would be positive, would show up as positive data. So we're looking for a positive difference here. So we want to make a 90% confidence interval for the difference in the mean decrease in blood pressure, and we would hope that there'd be a bigger decrease in the calcium group than there would be in the placebo group. Now we've mentioned you're going to see data presented in multiple ways. Crunch it is a piece of statistical software. So here you see data presented here, and you have to look and just see how the hypotheses are defined to understand that this mean here as a positive number shows that the decrease in the treatment group was bigger than the mean decrease in the control group. You see the standard error given to you here. That's necessary because we don't have detail. And then you see the sophisticated degrees of freedom calculation here as well. Then the significance test work is done. You see a test statistic and a p-value as well. So let's work with this data a bit. Okay, it says construct a 90% confidence interval for the difference in the mean decrease in blood pressure for the calcium and placebo groups. So why don't you pause me here and see if you can get your way through some of the panic steps and then check your work with what I uncovered. All right, so in this case, you can see that I've made a mistake here, so I'm correcting myself as I go through the videos. We're not testing, we're estimating. We've been asked to do a confidence interval. So we're estimating the difference in the treatment group decrease in blood pressure. So we're estimating mu t minus mu c, treatment group, control group. The difference in, it gets a little funky here, but the difference in the mean decrease in blood pressure, we're looking for a decrease. Between these two groups, between those receiving the calcium supplement, the treatment group, and those receiving the placebo. So again, we've defined the populations here. Assumptions here. Now, it's clear the men who are here were not randomly selected, but they were randomly assigned to treatments. So it limits our generalization in terms of how the men were selected, but at least we can see the experiment was designed well through random assignment to treatments. Assumptions here. We have 21 men. We have to assume that they were taken from a larger population to say they're independent of each other. And then we can argue that treatment groups are independent of each other, the control group and the treatment group, because of random assignment. So again, there's two parts to the independence check now. The subjects need to be independent of each other, and then the two groups we're studying also have to be independent of each other. All right, and we don't have any detail here, so we're just going to assume the differences in mean blood pressure are normally distributed. We have no data to work with, nothing to graph or anything like that. So in this case, we'll really have to make an assumption there. This is a two-sample t-interval for means, not a t-test. So let's be careful, don't make the mistake I made up at the top. So we're talking about an interval here. Right, then we're down into the mechanics of calculating the interval. So every interval is made up of an estimate, plus or minus a critical value, which is a certain number of standard deviations or standard errors. So in this case, the formula for interval would suggest that we take the difference in means. Now we don't have that detail, but off the Crunch It table, it showed us that that difference was 5.27. So we have a difference in means of 5.27. Plus or minus t star. Now, we don't have a t star here, but we do have the degrees of freedom given to us. So if you wanted to, you could go figure out what t is here using inverse t, 1.9 over 2, and we were actually given the degrees of freedom there at 15.59, and we get 1.749. It would also be okay to leave T star on the formula, but since we have the degrees of freedom readily available, it's not a big deal. 1.749 times the standard error. Well, I'd like to write the formula, but I don't have the detail. So we go back to the crunch it table, and it was given to us as 3.2878. So you can see the vocabulary is a little important here. You had to be able to pick off the crunch it table that the standard error, 3.2878, is what we have for the square root of standard deviation 1 squared over n1 plus standard deviation 2 squared over n2. And if you do all that work, you get negative 0.4773 to 11.0227. In this case, you really have to do this by hand because there's not an easy way to put this into your calculator without having the detail for standard error. So you have to put this do this calculation by hand. Then we can write a conclusion here. We're 90% confident the difference in mean decrease in blood pressure, pointing out how we're subtracting treatment group minus control group, is between negative 0.4773 and 11.0227 millimeters of mercury. And there's the crunch it table again that we pulled it from. Now, we can make significance test decisions, remember, off of a confidence interval, which we'll do in a second. But remember, if we're going to do that, it's a two-sided test we're making a comparison to. Here we happen to have a 90% confidence interval, so we can make decisions about hypotheses in a two-sided test using alpha equals 10%. So the next question here is use your confidence interval to discuss, is there an advantage to calcium over placebo if this is my null hypothesis against the two-sided alternative, which would mean that the difference here is not equal to 0, right? So we had this as a confidence interval. We had negative 0.4773 to 11.0227. So the question at hand here is, would we reject or fail to reject the null based on that confidence interval? What do you think? Well, the fact here is we'd fail to reject the null, and hopefully you've picked up why. Because 0 is in this interval here, or said differently, I see a decrease in the mean difference, and I see an increase, a negative mean difference and a positive mean difference. Now the words get a little dicey. This indicates, the positive indicates that in fact the calcium has had an effect and there's a positive mean difference, there's been a decrease in blood pressure. But this indicates the opposite. So we fail to reject, 0 is in the interval. So it's unclear if the treatment had a positive or negative effect. Now, that's against the two-sided alternative. You might have noticed here that, remember alpha is 10%, you might have noticed here that the p-value is actually less than 10%, but this was done as a one-sided alternative. So our p-value is actually double this. So we'd have to multiply this by 2, and it's roughly 0.13 as a p-value. So in fact, we can see here that the p-value is bigger than 10%. So again, you can use a confidence interval against a two-sided alternative to evaluate an alternative and a null hypothesis and make a fail to reject decision.